This is a short video showing my redesigned custom fifth axis for my CNC machine. In this front view you can see the spindle clamp and the lead screw which drives it. The lead screw is at 90 degrees to the Z-axis. My 800-watt spindle fits inside this clamp. The top view shows the lead screw and the lead screw mount. Looking underneath, you can see the pivot point located in the center. There's a small stop block preventing the spindle from going any deeper into the mount. The lead screw mount is a standard brass lead screw nut with a couple of thrust bearings. Taking the main body apart, you can see a good sized thrust bearing behind it. This is 50 by 30 by 12 and it pivots around an 8mm bolt. As mentioned, the spindle shouldn't go any deeper than the stop block, and that's so that the distance between the end of the spindle collet and the pivot point is always exactly the same. In this case, 60mm. Here's this new mount in action. I can easily get 45 degrees plus or minus, and this seems to be adequate for my work. I built a pencil holder that is roughly the same dimensions as my spindle. There's a small dowel with a spring on it to push on the end of the pencil and to give a little springiness to it, and a rubber band to keep it from falling out. You need some springiness to a pencil mount or you keep breaking the leads. I have a small bolt that'll go into an insert on the end, and with this I can adjust the length of the pencil stick out. I prefer about 30mm. I can use this pencil holder to trace out designs before I'm committed to cutting them. Grblgru produces the software for this, or the Gcode necessary for cutting out this pattern. In this case, I chose to put a simple Celtic cross on a vase shape. There's positive and negative curves here, and it's quite a challenge for any program to deal with that, and Grblgru does this easily. This feature is only seen in the DIYCNC Engraver model for in Grblgru. This is a standard Gantry style CNC machine. As you see, there's well-coordinated action between the X, Z, A, and B axes. Tracing through this corner is quite easy. As it turns out, my pencil pressure wasn't quite enough to get the tip of that design, so I turned in my screw a little and then a little bit more, and it started tracing. The reason for the parallel lines is I'm going to V-carve this design in, and with V-carving the pattern is put in and the depth of the cut depends on the distance between the lines. V-carving is difficult anyways, but I think over a curved surface such as this, it's really quite a challenge for any computer program. So when I was satisfied that this design looked pretty good, I took out the pencil holder, put in my spindle and a 90-degree V-bit, and carved out the design. The intersections where the lines crossed over were carved out in typical V-carve fashion, and it turned out very well. Thank you for watching.